Okay, we've got our 106 big bore kit unpackaged here, and a little bit of background on the kit. The pistons are forged aluminum and a performance piston set up with a really tight ring pack so that we can optimize the piston deck height. It fits in the same height or engine height as a stock motor would. So basically putting this on is just like putting on a stock top end. There's no boring of the cases. This is the biggest bore that we felt comfortable going with in the stock case, so there's no machine work. You don't have to pull the engine out to do it. You can just pull the top end off, put this top end on, and run from there. The pistons, when they come from S&S, are the same size front to rear. Okay, they're machined so precisely that we basically just hone the bore to a nominal dimension. And you'll notice that when you take them out of the box, the pistons aren't set in with a cylinder, or may not be. So it doesn't matter what cylinder goes with which piston. Pistons are interchangeable front to rear. There's no balancing required, so it's basically a direct replacement for your stock top end, minus, of course, tuning. Okay, so the next step is we just got our cylinders out of our packages and out of the packaging, and we want to inspect the cylinder for any debris in the passages, because before we want to install them, we got to wash these up. And so you're looking down in these passages, the bolt hole passages, the oil return passages, to see if you have any debris. And if of course you do, maybe there's a chip that got stuck in there from machining and didn't get washed out before it was packaged. That stuff does happen. So certainly inspect your parts and make sure that you get them cleaned properly. To get anything out of there, you can use a pick or like a pipe cleaner and some brake clean to get it clean. So the next step is going to be going to the wash bay and using some hot soapy water to get these things cleaned up, and I'll show you how to do that properly. It's important to wash cylinders because, of course, they have honing grit in them, basically little tiny rocks and stones that are abrasive to an engine. So when they come out of the package, they look pretty clean. But when you get down on the microscopic level, you'll see definitely that there is some debris in there. And one way to see that is just take a white paper towel and some ATF, automatic transmission fluid, on a rag and wipe it through there, and you'll see definitely that there will be some dark residue on that rag. So what we do is we fill a sink full of hot soapy water, and we just use some Dawn and get the cylinder in there. And I'm just using a regular old shop rag here, just soaked with the soap and water, and just, you know, get down to it, I guess. Scrub that cylinder up good. Get the outside of the spigot, and not too concerned with the outside of the cylinder, you know, but then now when you're done scrubbing it, just rinse off all your soap. And then immediately after you're done washing it and blowing it off, drying the part, you need to get some oil on it to keep it from surface rusting. And so before I came to the sink, I brought with me a stack of paper towels and a quart of automatic transmission fluid as well. You could use assembly oil or motor oil, whatever, as long as you keep that surface clean. I like ATF because it's red, and when I wipe it with a rag, I can see that I've got everything clean. Whereas if you use a brown oil, it's a little harder to see any dirt or debris. Okay, so I'm just going to use some compressed air here to blow the cylinder off. Of course, I got my safety glasses on. So right away I'm going to go over here and put some oil on a rag and get wiping on the cylinder. Get the outside of the spigot too. Anything that's steel basically needs to get a little oil on it. And I'll set that one aside and go do the other one. There we have it. Now that we're done washing the cylinders, we need to gap the rings. The reason why we gap rings is when the ring gets hot, of course, it grows. And if you don't have the proper gap, the ends can touch. And of course, when they touch, it'll bind in the bore and ultimately destroy the rings and the bore and everything. So we have to have a proper gapped ring when we assemble this engine. There's a couple of methods for doing that. We have the standard ring filer. You would mount this in the vise and place the ring on here like so, and basically turn the crank and gap it. So that's one method. The Tim Allen method would be the power tool method. Here we have a precision ring grinder that we can grind and accurately determine how much we take off. It has an indicator on here that shows you in thousandths how much you're taking off, and that's the method, of course, we'll be using today. So we'll set this aside. The other tool that you need to properly gap rings is a feeler gauge with the right range of thicknesses so that you can set your gaps properly. So let's get started with gapping rings. Basically, you take the ring and you put it in the bore that it's going to run in, so that, of course, it shows you the gap that it's going to run in. And what I use the piston, because we want to get that ring as square in the bore as we can, because if it's crooked, the gap is going to open up. So what I use is the piston, and the piston's got a nice flat deck right here underneath the ring lands, if you will. I just push it down with all 4 fingers here on each spot, and of course it's as flat as it needs to be for what we're doing. So I pull the piston out, and you can see right over here is the ring end gap. I'm going to take my feeler gauges, and essentially I'll start kind of small and work my way up. I got a 17 thousandths feeler gauge here. I'm going to try and slide that in between there, and it's not going to go. So I need to go smaller and see exactly what my gap is, so I know how much I want to remove. So I'm going to try a 15 thousandths gap, and that one's tight as well. Here's a 12. And a 12 is starting to go, but it's tight. So I probably got somewhere around a 10 or 11 here. Here's a 10. And the 10 goes pretty free. So the target I'm shooting for in this bore, there are rules of thumb for ring gaps 4 thousandths per inch of bore. And so if you had a 4-inch bore times 4 thousandths per inch, you would have a 16 thousandths ring gap. Some specs are 5 thousandths per inch of bore. So we're going to kind of shoot in between those two, and I'm going to target basically a 17 thousandths gap. And I'm at it down around 10 now, 10, 11. So I'm going to put it in my ring grinder, pull it out of the bore, and put it in my ring grinder, and try and shoot for, you know, a 6 or 7 thousandths removal. So what you're looking for here when you of course mount your ring or hold your ring, depending on whether you're doing the bench grinder or the power grinder, you want to make sure your ring is as, you know, square to the grinding media as you can get it, so that you don't have a crooked gap when you get done. So get this one locked in here. Turn on my machine. Kind of see where you know, where the indicator stops, and you can zero it. So maybe I've taken off a thou or two. I mean, I can take it out of the ring grinder and come back as I need. So I'm just going to take off somewhere around 5 thousandths. Okay. Now I'm going to go back to the cylinder and confirm how much material was removed. So to me, that's a 17 thousandths gap, or as close as we need to be to one. So we'll move on to the second ring and do the same procedure.